For our first example problem, we have a 2,000 kilogram car moving at an initial speed of 25 meters per second along a horizontal road, and it skids to a stop in 60 meters. We're going to find the work loss due to friction and find the coefficient of kinetic friction. So the first thing we need to realize is that we've got some amount of initial kinetic energy, and it's going to skid to a stop, so the kinetic energy is going to eventually drop down to 0. So I use my, because we have loss of work, we're going to use the workout formula, or the energy equation with work factored in. So our workout equation, change in kinetic energy plus a change in potential energy equals negative workout. Uh, and now it's just a matter of plugging numbers. Or, we can expand the equation first to, have our kinetic energy final minus kinetic energy initial. And backing up, what should we do with potential energy? Well, if this thing is moving on a horizontal road and it skids to a stop on the same horizontal road, well, we don't have any potential energy. So potential energy starts at 0 and ends at 0, so it's just 0. We can essentially get rid of it. So your workout is a situation where your final kinetic energy minus your initial kinetic energy will give you your work, and that's the amount of work you lose due to friction. And the initial kinetic energy is pretty easy to figure out. That's 20. We have our velocity or our speed, so it's just mv squared, initial squared, over 2. Plugging in our numbers, we should get an initial kinetic energy of 625,000 joules. 625,000 joules. So that's our initial kinetic energy. And our final kinetic energy, because it stops, our final kinetic energy, that's kinetic energy final, that's equal to 0. It stops. It has 0 velocity. Okay, so we can say 0 minus 625,000 joules and solve for our workout, and our workout is going to be equal. I forgot to pause the video, so you guys saw me write all that in. Anyway, so workout is equal to 625,000 joules. And now we need to figure out the coefficient of kinetic friction. What that means is workout is equal to the force of friction. That's the one that's taking the work away from the energy, and multiply it by how far it goes, the distance or displacement. Well, we've got that, 60 meters. So we can figure out our coefficient of friction. Here's how. Work equals force times displacement. Well, the work that we're talking about is the work out. The force that is taking the work is friction. So 625,000 joules is equal to the force of friction times 60. So what's the force of friction equal to? force of friction is equal to 10,400. Well, that's great, but I'm trying to figure out the coefficient of kinetic friction. Okay, well, what do I need to do that? Well, friction is equal to the coefficient of kinetic friction times force normal. We have a situation where we are on a horizontal plane, horizontal road, so the force normal is equal to the force weight. Well, they give us the weight, force weight is mg, therefore force of friction is going to be equal to kinetic coefficient times force normal is equal to force weight in this scenario because we're on level ground. So force weight is equal to mg, therefore force normal is mg. We plug it in, mg, and we can solve for the coefficient. Plug in our numbers and solve. Coefficient is equal to 0.530.